Our sun is a very special star. And by special, I mean that it's the only one we know for sure has life orbiting it. In fact, the sun is pretty boring. It's an average yellow dwarf. There are billions just like it in our galaxy. Every day, the sun does the same thing it's always done, fusing hydrogen into helium in its core, generating light and heat in the process and shooting plasma into space with its solar wind. But occasionally, something happens that makes our usually so predictable star act out. Like on February 2021, when it almost exploded. This is the story of the most violent outburst the sun has had in more than a century and a half. An event so big that it not only rocked the entire solar system, but also almost knocked humanity with mullet, molest, rude, Q, maud, rude, bead, eed, with new into, in you, with reu, si perpiu, to yuk to teed, and to we, to you, stack out, if you, the year is 1859, and astronomers are looking up as they do. And some are focusing on the sun because they've heard there might be something going on. For years, scientists have been watching sunspots, those dark blotches on the sun's surface that come and go over time. Some are larger, some are smaller. Some come close to Earth, while others stay far away. People have been tracking them since 1610, when Galilei Galilei first saw them with his telescope. And by now, we know that sunspots are regions where the sun's magnetic field is twisted and turned in such a way that it blocks the light coming from the hot plasma below. This gives them their dark appearance. We also know that sunspots can get very, very big, bigger than Earth, or even multiple Earths lined up side by side. And we know that sometimes those spots can launch solar flares and coronal mass ejections, CMEs for short, which hurtle matter away from the sun at millions of kilometers per hour. But nobody knows any of the details. Scientists don't know what causes sunspots or why they sometimes send CMEs hurling toward the Earth. All they can do is watch and record. And in 1859, they are about to witness something truly spectacular. On September, astronomer Richard Carrington was looking at a sunspot when he noticed an intense flash of bright light coming from the sun. Carrington later described it as a white patch of dazzling brightness suddenly appeared in the middle of the sunspot and lasted about 5 minutes. It was not like a flash of lightning, but partaking more of the nature of a vivid aurora. This white patch was the largest solar flare ever recorded at the time, and it happened again the next day. At the same time as these flares, Acme was racing away from the sun. And luckily for humanity, Earth was in its path. The charged particles from the CME reached our planet within 2 days of leaving the sun, triggering a geomagnetic storm unlike any that had been seen before. In modern times, we are able to measure these storms with a worldwide network of observatories, and we assign them a number from 1 to 9, 1 being the weakest and 9 the most violent. The higher the number, the more dangerous the storm is for our planet and our technology. And the storm of 1859 would easily be a G9 on this scale. It hit the Earth so hard that telegraph systems across the world began working without being connected to the power at all. They were running solely on the energy from the solar storm. There were reports of telegraph operators receiving messages without even touching the key. People could send telegraphs halfway round the world by simply walking up to a telegraph pole and talking into the transmitter. There were also auroras all over the world, including here in Honolulu, where they appeared as shimmering curtains of light hundreds above the Pacific. The northern lights were even seen as far south as Cuba and Hawaii. And even though people were amazed and newspapers reported on these strange occurrences, the full impact of the event was lost on most. It wasn't until the dawn of the space age that we realized how close we had come to disaster. You see, the storm disrupted the flow of electricity through the upper layers of our atmosphere, setting up electric currents around the globe. And those currents continued flow for weeks after the initial impact. And because this happened at a time when most of the world's infrastructure was being electrified, these induced currents caused widespread damage. They burned up transformers, melted telegraph lines, and destroyed miles of track on railroads. Some historians estimate that the damage wrought by the storm in 1859 would be equivalent to more than $6 billion today. It took decades for engineers to upgrade the electrical systems and protect them against future solar events. But even so, it's a wonder that nobody noticed the connection between the solar event and the widespread blackouts, because it wasn't until 1921 that a solar storm of similar proportions hit Earth once again. For most of us, this is old news. You see, in February of 21, a massive solar storm hit the Earth and disrupted communications and the power grid in many countries. Social media platforms went down, stock markets froze, and satellites were knocked offline. This event was estimated to be a G8 storm, the second highest on our modern scale. And while the financial impact of the February 2021 solar storm was measured in the millions rather than billions, the potential for disaster was just as high. And even though this event didn't cause nearly as much damage as the one in 1859, it was more closely watched and understood. So, it gives us a better idea of how close we came to catastrophe. The storm happened as a result of a solar flare that erupted from sunspot R 12,192. And the flare was particularly interesting because it was the first X-10 event recorded by NASA's Solar Dynamics Observatory, which began observing the Sun back in 2010. An X-10 flare represents the most extreme end of solar activity, and these flares are thought to happen only about twice a year, so seeing one is quite rare. And this one was especially powerful. It sent an estimated 200 million tons of matter hurtling toward the Earth. That's enough material to fill up about 70 million double-decker buses. And thankfully, the Earth passed right through the center of the CME by the time the storm hit. The CME had compressed the atmosphere in Earth's upper layers, creating an electromagnetic pulse, or EMP, that fried transformers all over the US. Even though many of these transformers were housed inside of substations with Faraday cages to protect them, the EMP was strong enough to break through the shielding and damage the equipment. More than 100 transformers blew up in Texas alone, and more than 400 were damaged in total. Power companies didn't expect that an EMP could break through the Faraday cages because they hadn't been designed such an event. And that meant that many of the transformers weren't insured against this type of damage. And this isn't the first time that something like this has happened. In 1989, a solar storm caused a magnetic crochet effect in the Quebec region of Canada, knocking the entire province offline for 9 hours. And a similar event in 1962 caused a widespread blackout in the US and Canada. The problem is that as more and more of our infrastructure becomes computerized and dependent on electricity, the effects of solar activity will become more significant. We're also increasingly putting important electronics into space, and so the risk they'll be affected by a solar event is also growing. A few months ago, for example, a solar storm caused the loss of 40 newly launched Starlink satellites, and it's only a matter of time before a major satellite like the International Space Station or a GPS constellation is knocked offline by a solar event. So you can see why space agencies and government organizations around the world are keeping a close eye on the sun's activity. Every day, satellites scan the sun and relay data back to Earth about sunspots and solar flares. And that data is used to create a forecast of space weather for the coming days. And although we've come a long way since the days when Carrington was staring through a telescope in his backyard, we still have a lot to learn about the sun. And the biggest mystery is what happens next. As I mentioned earlier, the sun is a very special star because it's the only one we know for sure has life orbiting it, but it's not unique in the grand scheme of things. In fact, the sun is pretty boring. It's a yellow dwarf, Every day, the sun does the same thing it's always done, fusing hydrogen into helium in its core, generating light and heat in the process, and shooting plasma into space with its solar wind. But occasionally, something happens that makes our usually so predictable star act out. Like on February 2021, when it almost exploded. This is the story of the most violent outburst the sun has had in more than a century and a half, an event so big that it not only rocked the entire solar system, but also almost knocked humanity off the internet.